assignments right here. I'm going to pull one up at a time, do a couple problems. Do what I can to help you out. So let's see, we got making appropriate scatter plots. So what I noticed when I did this, actually, I did this before I started the video, and I got the first one wrong. That's okay. You'll see me probably on the video get one or two wrong, and then I'll go through and what did I do, and that helps you guys learn too. So this one is getting at two things. One thing is the idea that if you can spread out the data in a graph like A or C, it's a heck of a lot easier to read than B or D. And the second thing is which variable goes on which axis. So what goes down here is always your X variable. And what goes up here is always your Y variable. You can look at it like Y depends on X. And they'll phrase it in the question sometimes. So the explanatory variable goes on the X-axis. That's the one that's explaining what's going on. So we are trying to predict how long people use the internet. If we're trying to predict it, that's the Y. Based on their age, if we're saying it's based on that, that's your X or your explanatory. So we want graph A in this case because the X variable is age, so it must be A or B. And A is just not easier to read because it's so much more spread out. Okay, let's go back to that. Hold on. So I'll do another one of those, but it's basically just look and see which the X and Y, and then make sure your graph is spread out. Two of these multiple choices, you can just eliminate right away because they're so close together. So B and D are obviously terrible graphs. So you're down to A or C, and then it's just what's the explanatory variable, dosage or pain. So we read through the question and see what they're trying to figure out. We're trying to find the impact of different dosages on their pain levels. So the dosages are what's making an impact, that's what's explaining things, and the pain levels are what we're measuring as a result. So the dosage is your X, the average pain level is your Y. So dosage is X, that means A. So that's that one. You're looking to see which is X and which is Y, and then pick the one that's not super condensed. All right. Positive and negative linear associations from scatter plots. So a positive association looks like this, meaning when one variable goes up, the other one goes up, or if one variable goes down, the other goes down with it. They move together. Negative association look like this, meaning when one variable goes up, the other one goes down, or if the first one goes down, the second one goes up. And sometimes you'll get neither, where it's just like your graph is just kind of a bunch of random nonsense, and there's no association, there's no pattern there at all. This is asking for the relationship between average income in a city and the average rent for a one-bedroom in that city. So if I imagine like the average income along the x-axis and the average one-bedroom along the y-axis, well, as the income goes up, I'm expecting that the bedroom price will go up also. It makes sense to me that the more money people make in that city, the more that people can charge for apartments. So when they're both going together, up and up or down and down, if the average income goes down, then the price of the apartment goes down. But that is a positive association because they're both moving in the same direction. This is not a linear association at all, because that's a parabola. So it's not a positive linear association, because that would look, positive looks like that, negative looks like that. I'm not 100% sure right now whether this is non-linear association or no association. I'm going to say it's non-linear because there is a pattern there. It's just not a linear pattern. So there is an association, there is a pattern, it's just not linear. It's a problem. No association would look more like just there's nothing. There's no sense I can make out of that. There's no pattern at all. All right, so then we go to describing trends in scatter plots. So this is going to ask you to look at the graph and then your x and y values, or variables, and then kind of talk about things. So this is your x, or your independent. And as this changes first, and the y responds to it. So y, I know this is going to take a long time to write out. I'm going to do it anyway. It's important. Y responds to x. So, does a higher infant mortality rate have a longer life expectancy? Well, as my infant mortality rate goes up, the life expectancy is going down. So A is not true. Higher infant mortalities tend to have shorter life expectancies. Yeah, as this goes up, this appears to be going down. So as I go to the right, the values get smaller. So that's B. So no clear relationship. Again, it would be just this, just like a jumble of nonsense in there. Like this. So this is not true that as it goes up, it's not true that it goes down. There is just no clear relationship because that's a jumbled mess. So that was not too bad. Describing scatter plots. Okay, so there are 4 things that you are supposed to describe, and they're given to you right here. Form. Form is whether it's linear or curved, basically. So this is making a linear pattern because I can draw a pretty reasonable. I didn't, but I could draw a pretty reasonable line. Kind of represents that pretty well. So as the release shear goes up, the average rating goes down. So songs are getting worse and worse. Okay, form is linear or curved. Direction is positive or negative. Strength is strong or weak, and this one's strong because most of the points are pretty close to that line. I could also go with moderate there. Weak would look more like, yeah, there's a pattern, but it's kind of hard to tell there's a pattern. And it says there are no outliers, so they discussed it. And then you just mention are there outliers or not. So when you're describing these, I want to tell, is it linear or curved? Is it positive or negative? Is it strong, moderate, or weak? And are there outliers or not? And this has all 4, so that is solid. So here they give you a description. Moderately strong, that's representing the strength, and if you put strong, you'd be okay. If you put moderate, you'd be okay. But they're representing the idea that most of those points are not like perfectly on that line, but they're pretty close. If you put moderate, you'd be okay. If you put strong, you'd be okay. They're pretty flexible with that. It is positive, that's because we're going up. It is linear, that's because we're making a line, not some sort of curve. And I don't see any obvious outliers, that's like way over there, way up there. So it does describe all the things, so I'm going to say nothing's missing, and there we go. Correlation, coefficient, intuition. And then you got a quiz, and I'm not going to go through the quiz. So, do I just move these? Not really sure what I'm supposed to do here. Hold on. I know that. Where's 0.55 and 0.89? There's no numbers. Let me refresh. Are there numbers here? What is going on? Well, let me try to talk through this. In general, and hopefully yours works. Mine does not appear to be showing the numbers. Like there must be numbers in here somewhere. But let me just okay, so I can tell the numbers from down here and I'll be able to talk through. So obviously we got 0.55 and 0.89. Those are both positive numbers, so that must be B and D. Which one is stronger is B. So you take the bigger number and put it with the stronger one because we're closer to the line in general here. So I can label those two. And then the two negative numbers they gave you, just looking by their answers, must have been negative 0.76 and negative 0.9. Negative 0.9 would be this one, because negative 1 is a perfect, like negative 1 would be dots, like perfectly on that line. Negative 0.9 is pretty close to that. That's a stronger relationship. And these are more spread out. It's still negative, but this is going to be your negative 0.76. So basically you got, it looks something like this. This would be 1 would be a perfectly strong relationship upward. Negative 1 would be a perfectly strong relationship downward. 0 would be a bunch of dots. 0.5, maybe kind of like that. Like we're going up, and we can tell we're going up, but it's not perfect. And then negative 0.5, something like this. And you're basically just eyeballing them and trying to get as close to those as you can. There we go. We got numbers. All right. So I got two negative numbers, negative 0.71 and negative 0.92. The stronger one, stronger one is negative 0.92 because it's closer to negative 1. This is a stronger negative relationship than this one is. So we're going to do this. Scatterplot D is going to be this one. Scatterplot B is positive but pretty weak. And then scatterplot A is positive and strong. So it would look like this. Again, the closer to 1 or negative 1 you get, the stronger it is, meaning the closer and like tightly packed. So that is tightly packed, that is tightly packed. These are a little more like spread out. You get the pattern, but you're spread out. So that's why it's closer to 0.